Hi, here's another representational podcast. Today I'm going to tell you about how to convert a couple more sentences into sumo expressions. The particular sentences are from a paper that I'm working on with Professor Steve Reed, illustrating forms of reasoning in psychology. So here's an example. The number of quarters a man has is 7 times the number of dimes he has. The value of the dimes exceeds the value of the quarters by $2.50. So what I'm going to start out doing is just trying to capture little bits of this expression, and then we'll put them all together in a single coherent logic statement. So the number of quarters a man has. Okay, so we've got to have a man. So instance m human. We've got to have a bunch of quarters and a bunch of dimes. So let's do that. So these are collections. Okay, in sumo. Dimes and quarters. So here's a second collection. Okay, and then we need to start talking about what are the members of those collections. So the collection of dimes is made up of dimes. And the way we do that is with a relation called member type. Let's just go check on it. So this is important. Even when you think you know how things are spelled and what the argument types are, it's really a good idea to check them in sumo. Even though I'm the author of sumo, I don't remember every particular term that's in the theory, and in this case we can see why. I've actually added in an extra S, I think. Yeah, member type is the name of it. And as you can see, its first argument is a collection, and the second type is a setter class. So the member type of this collection of dimes is going to be something like United States dime coin. Of course, that one I don't remember offhand either, so let's take a moment to look at that. Look that one up. And dime coin. Okay, so it's not dime coin, it's United States 5-cent coin. Aha. So let's copy that one over. Okay, and we need the same or similar thing with the collection of quarters. So let's United States quarter coin. Let's double check that one. Okay, there it is. Great, that's right. All right, now we talk about how many members are in the collection, and we do that with member count. Let's look for member count, make sure I've got that correct. Member count, okay, there it is. Takes a collection and an integer, which is the number of members in the collection. So we've got D, and let's call that dn, the number of dimes. Member count q, the number of quarters, and then we want a relationship to say that the number of quarters is 7 times the number of dimes. So you're going to need to say, let's see, number of quarters is 7 times the number of dimes. So that's quarters. And then we're going to need to use a function, multiplication, right? Multiplication fun. So all of the basic arithmetic operators are in sumo. They're multiplication, fun, addition, fun, subtraction, fun, etc. So these are functions. You can think of them just like functions in any programming language. They return a value. Actually, in logic, they stand for the value. The whole expression is equivalent to the value. It denotes that value. But you can think of it as it returns the value. So multiplication fun, 7, and the number of dimes. Okay, so there we go. Oh, we need to also say that the man possesses these things, right? So the sumo expression for owning something is possesses. So we've got M, D. Actually, let's check that. check the argument order. Sometimes I forget them. In general, in Sumo, the smaller thing goes first, but that isn't always possible to have an intuition about what thing might be smaller. So let's just check this. Okay, possesses, the agent possesses an object. Okay, so M, the human, possesses the collection of dimes, and P-O-S-S-E-S possesses the collection of quarters. Okay, there we go. So we've got the relationship between the number, we've got the coins, we've got the collections, we've got the human possessing them, and the value of the dimes exceeds the value of the quarters by $2.50. So now we need to talk about value, and the way we do that in Sumo is to have the relationship monetary value. Let's check that one. Monetary value. There we go. Okay, so it takes a physical. That physical, of course, can be both an object, could be an object or a process. Could be a process like giving an invited lecture that you get paid for. In this case, it's just a physical object, and a collection is a physical thing. So the monetary value of the collection D, let's call it dV, the value of the collection of dimes. Monetary value of Q is QV. Okay, now we need to relate these values together. And so we're going to say that the value of the dimes, dV, exceeds the value of the quarters by $2.50. We want to add $2.50 to the value of the quarters. So we do that with addition fun, and then we want to have QV, the value of the quarters. And to add it together, then we need to create not just a number, but a number with units. And the way we do that is with another function, measure fun. I'll look that up so we get the arguments right again. So measure fun, there we are. Measure fun relates a unit, a real number, and a unit of measure. So in this case, we're going to have a real number of 250, and we're going to relate it to United States dollar. Okay, and we got 3 opening parentheses, so we need 3 closing parentheses. All right, I think that is everything. Now we just need to pull it all together, and we're talking about a particular example. We're not talking about a rule. We don't need a conditional or an if-then statement. We need an existential. So we want to say there exists, and then a long list of each of these variables that we've used. M, D, Q, the number of dimes, the number of quarters, the value of the dimes, the value of the quarters, and I think that should do it. We need to join them together with a conjunction, because all of these things are true. 1, 2, 3, 4. I generally like to indent with 2 spaces per level, but it's up to you. Some people use 4. Just the main thing is try to be consistent. That really helps in understanding, visual understanding. If you're a programmer, you're going to be used to this sort of thing anyway. So let's just add these in as quickly as I can. Nice to indent the other parentheses too. Let's just take a moment to do that. 2, 3, 4, 1, 2, and then indent this 1 level more. Okay, and we added 2 more parentheses at the beginning for the existential and the conjunction. And there we go. That is it. So that's the representation of these 2 sentences, and hopefully you've learned a little bit about arithmetic functions and typed units in Sumo, and how to convert a sentence into a logical expression. All right, thanks very much.